For those who don't know me, I'm Stephen Kitt. I work for Red Hat, and I'm active all over OpenDaylight, pretty much, but mainly in OD Apparent and OVSDB. And so we're going to talk about semantic versioning. I'm going to start by saying what it is, rather than why we're talking about it, and then we'll go into the why and how if it's useful for OpenDaylight and what we should do about it. So the first part is me explaining the semantic versioning spec, and then I'm hoping we can have more of a discussion afterwards. So semantic versioning is a concept. Basically, it means associating meaning with version numbers of software packages, whatever. And there's a spec on semver.org, and so the 11 next slides, they're just a retranscription pretty much of that spec. Most people agree that it's that spec is a sensible definition of semantic versioning, but lots of people then don't necessarily read all 11 points carefully, and it can end up being misused. But that won't happen on OpenDaylight, will it? So the first point of the semantic versioning spec, and the most important one, is that it only interests itself with public APIs. And it's up to you to define what a public API is. You can say it's anything that's in my developer's guide PDF, or you could say it's anything that has vague Javadoc, or it's anything that's public in Java terms and not API terms. So that's something that we need to agree upon, I guess. And then anything that's not in the public API that you've defined is not covered by the semantic versioning spec. So that means that even classes that are public or public methods that are accessible in Java, if they're not part of your public API, all the guarantees that come with semantic versioning don't apply. So there's still a certain amount of freedom, and it means that you do need to document your stuff, because your users are going to have to rely on coding using documentation rather than coding using implementation, which I think is nice, but we're not quite there yet in OpenDaylight. The second point is that, so semantic versioning defines a canonical version layout, which isn't too surprising compared to what we're used to with version numbers. So there's 3 components, X, Y, and Z. X is the major version, Y is the minor version, and Z is the patch version. And then the rest of semantic versioning defines rules about how you change those different components. All of those 3 components are always non-negative integers, starting with 0, but they can't have leading zeros. So 01.2.0 is an invalid version number. But 0 dot something is fine. It's nice because it avoids octal surprises. The third point, and this is one that sometimes gets forgotten, is that once an artifact is released with a version number, it never ever changes. So you get some projects which ignore that, and they'll realize that there's a nasty bug in something that they've just released, and they'll silently update the tarball or move the tag, as we were discussing about OpenStack just a few minutes ago. Although it's not quite the same context there, but if you do this, bad things happen. So basically, once you've defined what your release artifacts are and you've released something with a given version, we can take a hash of that, and it should never ever change, ever. Point 4, and this relates to what Andrew was asking about version 0. So version 0 does exist, but there are no guarantees as far as semantic versioning is concerned. It doesn't apply until version 1. So that's nice. It means that when you're starting something, you have no idea really what would make sense as a public API and so on. So you use version 0, 0.1, 0.2, and so on. As long as you don't have version 1 or greater in the first component of the version, there are no guarantees. part 5 is, so as a consequence of that, version 1.0.0 defines your first public API, and if you're starting a new project, it's fairly important to wait to get that reasonably right, because once you've started that, it's going to constrain things for the future. So one thing that isn't covered in these points, but I think it's worth pointing out, is that we're not in JVM land here, or should I say rather Java JDK land here, so you are allowed to remove things. It's not because you've defined something in a public API that you're stuck with supporting it for the rest of your life. But it is important to make at least a reasonable effort to get version 1.0.0 right. Right, so then what are the rules for incrementing all these different components? We'll start with the last one, which is the patch version. And so if you make a new release of a piece of software or an artifact that has only bug fixes that are all backwards compatible, then you only increment the last part of the version number. So you'd go from 1.0.0 to 1.0.1. And it says here a bug fix is an internal change fixing incorrect behavior. And so this is incorrect behavior as defined by the public API. So if there's a bug in your code that means that it doesn't match the documented behavior, that's a bug, and you can fix it with a patch increment, even if it breaks stuff, because people shouldn't have been coding to your implementation, they should have been coding to your documented public API. So that would be a big change for OpenDaylight as it stands currently, but I think it would be quite good to have. So the next step up is when you're adding new features, but in a backwards compatible way, or if you're deprecating existing functionality and you release a new artifact, then you increment Y. You can if you want, but you don't have to increment it if you're adding new functionality to private code. So that's stuff that isn't part of your public API. But just to show people that code is moving, because despite what the semantic versioning spec says, you end up with certain expectations. If you go from 1.0.0 to 1.0.1, people will expect that there are only so many lines of code that have changed. And if you've been fixing bugs and at the same time preparing a huge change, and so there's a couple of patches in there that have 5,000 lines of code added, and you go from 1.0.0 to 1.0.1, some people might be surprised. So it'd be legal in this, according to the semantic versioning spec, but if you want, you can do 1.1.0. Obviously, if you're releasing a new minor version, you can include bug fixes, that's fine. And when you increment Y, you reset Z to 0. So you'd never go from 1.0.1 to 1.1.1. You'd go from 1.0.1 to 1.1.0. If that makes sense. And then the last component, the first one, major versions, so that you change that, you increment it if you introduce backwards incompatible changes to the API. And of course, while you're doing that, you can still introduce bug fixes and new features that are backwards compatible, and you reset Y and Z to 0. So the expectation is there that if you go from 1.0.0 to 2.0.0, or 1.anything.anything to 2.0.0, your users know that they're likely to have some work to do before they can switch to 2, because there's probably stuff that's disappeared, so deprecated APIs that you've actually removed in version 2, or some changes you've made require changes to the code that's using your artifact. Then point 9, pre-release versions. So now we're going to get into more sort of the kind of details that you don't necessarily need to know all the time, but it's good to have it in mind. We have the 3 components, x.y.z, and you can add extra stuff afterwards. And this defines, the next 2 slides define how that's interpreted. So if you start with a dash and then alphanumeric characters, that's pre-release versions. So you can imagine that as it would be like a graph, and you're trending towards your version asymptotically. So 1.0.0 dash alpha, that's an alpha release of 1.0.0. So it's not quite 1.0.0, but it's getting towards it. And so that means that 1.0.0 dash alpha sorts less than 1.0.0. So if you release an artifact and you call it dash alpha, then when you remove the dash alpha, your new release artifact will be considered as newer than your alpha release, which is nice to have. Yeah.
So basically, the GA suffix or service releases, service packs are not according to the standard?
Not according to the semantic versioning standard. Yeah.
Okay.
So yeah, so Maven doesn't quite do semantic versioning. You know, when you see like nete 4.0.33.final, that's not a semantic version. Because
the GA is without the dash.
Yeah, the GA is without the dash. Yep. And so you can, the pre-release versions are sorted alphabetically, which works out well for alpha, beta, and gamma release candidate. But if you get that wrong, you can end up surprises. But you can always add extra stuff afterwards, and that sorts later. So alpha comes before alpha.1.
So it's ASCII-betical?
Yeah, it's ASCII-betical. Okay. So 1 comes before alpha. You can also add build metadata. So instead of starting with a dash, you start with a plus. And that sorts after the version you specified. So 1.0.0 dash alpha plus GD7BB7C. So that's the Git version description that you get, that Git will give you if you ask it nicely. That sorts after 1.0.0 dash alpha. And so there are typically two ways of doing this. Well, actually, no, one sensible one, which is to use dates, as in the second example there, because they sort nicely. Git hashes don't. So that's a bad idea, the plus G1 thing, G thing there. But it's nice, sometimes it can be nice to have the Git hash just to find things because people don't know tags. And the last one is precedence rules. So that they should be reasonably obvious given what I've said so far. If you want to compare two version numbers according to the semantic version spec, the way you do that is that you take the first three parts, split them up, major, minor, patch. They might have pre-release stuff, they might have build stuff. The first different element determines the precedence, and you compare the major, minor, patch components numerically always. Pre-release, it might be numeric. If so, you compare it numerically. Otherwise, it's ASCII-betically. Numeric elements are always lower than non-numeric, and so null pre-release identifiers are lower than non-null. That's just a complicated way of saying that if you add extra pre-release components, they sort later. So you could call your versions 1.0.0 dash alpha and then 1.0.0 dash alpha dash beta if you really wanted, and that would sort after dash alpha. And actually, the stuff I was saying about Git tags being bad for builds is rubbish because the build part is never taken into account for precedence rules. So it doesn't matter.
So what happens if you have
Yeah, if you have 1.0.0 plus 1 and 1.0.0 plus 2, they're considered as equivalent. I don't know what happens. It's undefined in the spec, undefined behavior. Yeah, so the idea is you never use build stuff on its own. You make sure that your version is, well, yeah, you bump your version or add extra pre-release information, and the build stuff is just a way of adding information so that you can find things later.
Well, what I I don't want to use build information in OpenDaylight in the short run.
Yeah.
And so what is it by split into identifiers? Is it?
Pre-release. Yeah, so you can say dash one. You can have 1.0.0-1.0.0 if you want.
And how is that done in precedence? How is it tokenized? Or is that should I go read some?
It's tokenized using dots. So dots separate components in the pre-release version as well as the major ones. And then after that, it's alphabetically. So anything. So you're allowed. So I elided some information there. So it starts with a dash, and then inside it, you're allowed to have any alphanumeric character and dash and dot separates elements.
Okay, and the next, you're allowed to have more dashes?
Yes, you're allowed to have more dashes, but they don't separate things. But no, yeah.
Semantic versioning.
Yeah.
Maven.
A completely different take on
Yeah.
it. For example, if you start publishing these artifacts into Nexus repository, it's going to sort them out alphabetically. So what you'll end up with is your release coming after your RC, because RC is capital.
Yeah.
And if you try to pull the latest artifact, those suffixes will ruin your day. So please don't use them ever. Just use the 3 numbers and be done with it.
Yeah.
Maybe 4, but just use numbers. Don't do any suffixes. Otherwise, it's gonna break like there's no tomorrow.
So if we
Or the suffix should really be only used for things that aren't release, and it should be changed if you must bump the minor. I mean, you could certainly have. I mean, Maven would work correctly if you did, 1.0.0.alpha and then release 1.0.1 flat, right? Because as long as you assume that the suffix is attached to your version. Or is the short version you don't use them?
Yeah, but Maven splits on dots.
So
Everything.
the Maven will take the alpha before the 1.0.0.
Yeah, there are some keywords have specific meanings in Maven, and it knows how to handle .alpha and
So with
.beta.
prefix, it will be a newer version than without a prefix, the suffix. Sorry.
yeah, but if you do something like hydrogen and helium, then hydrogen comes after helium.
Yeah.
So suddenly you're moving back.
Yeah, which is also why you should never have version code names in a version number.
Okay, so the short version is don't use suffixes. Is that?
Well, no, because suffixes are nice because when you're approaching a breaking change. So say you know that you've got version 1 out already, and you're going to break API, so you want to switch to version 2, but you don't want to inflict major pain on. Well, you don't want to promise stuff yet, and so you're not ready to publish a public API that you're going to stand behind for version 2 in its entirety, but you also don't want to start releasing 1.9.99 or whatever because you're going to go and break everybody.
Until you aggregate everything together and bump one version.
Yeah, but you still want to say, when you start making breaking changes, you still want to be able to say, I'm releasing 2.0.0-alpha. It's not the real 2 yet, but it breaks stuff for version 1, so if you're on version 1, don't switch to it yet.
How will they both work with Maven though? I mean, again, there is a big problem with using the suffix in Maven.
Yeah.
Assuming the official release is without any suffixes, right?
Yes. Yeah, and Maven well, there are plugins for Maven, but actually I was going to.
Keep going. We can talk about how it's broken for OpenDaylight next.
Yeah. So, well, first I was going to say what all this means from downstream and upstream's perspectives. Yes, 11 was the precedence rules.
Oh, okay. Oh, we went backwards. Got it.
Yeah. So, why is this interesting? The big one, from my point of view, is that for downstreams it means that they can start using version ranges, and so instead of so in OpenDaylight, well, during development phases we all just use snapshots, but if we want to switch to release artifacts, we don't want to specify specific version numbers, I think, because otherwise, whenever anybody makes a change to Yang tools or controller, you'd have to patch everyone. But we could say I want to use Yang tools version 1, open bracket, comma 2, closing parenthesis, and that tells Maven that any version 1 Yang tools artifact is okay, but not version 2. And we trust the Yang tools guys to do their job correctly and not break anything. And remember, they're allowed to fix bugs, so they can. So for example, the Yang bug fixes that happened in Beryllium, they wouldn't have required a major version bump because that was a bug. The public API was correct. The implementation wasn't. And when you fix that bug, even though it might break everybody that's using your stuff, you don't have to do a major version bump because your users should have been coding to your spec and complaining about that and not.
Just to be clear, just because you don't have to bump your minor version doesn't mean you shouldn't tell people.
No. The major version. But you communicate.
This is not meant to accuse people of anything, but just
No.
establish best practice.
Yeah, just to establish best practice.
It's just, please, there's two different pieces here. There's our aspirational goals of encoding all of our meanings into versions, and
the reality.
A reasonable human being that won't get shivved in a parking lot at the OpenDaylight Summit.
Not that people get shivved in parking lots at OpenDaylight summits, but
Exactly.
not yet anyway. But so you are allowed to do a major version bump even if it's not strictly necessary if you want. So it's up to you to decide, because that means then your users will have to change things, at least their version number, to actually use your new artifact.
So that's used for things like communicating deprecation in order to do...
No, deprecation is just a minor. But then when you remove the deprecated API, that's a major. And so the other thing from downstream's perspective is, and that's something that we don't have currently, when an upstream project introduces a new feature, then you change your lower bound to that version number so that you're guaranteed that you've got the new feature. And this would actually help us with some of the dependency cycles that we've ended up with in OpenDaylight. So I haven't thought through all the details yet, but for example, when SFC and OVSDB, they define Yang models that they use, each uses the other's Yang models. So I'm going to come to Yang revisions because there are other issues there. But if you think of it just as a public API, then you could say SFC adds a public API. So this is a new functionality, and so they release an artifact. OVSDB then depends on that minor version at a minimum, which means that they're guaranteed to have to pull in a dependency that supports that. Then they release their stuff that's based on what SFC have provided, adding the new stuff that SFC also requires back, because we're in a dependency cycle. Release a new artifact, and SFC bumps its dependency on OVSDB, and that way you've got something that works and that you can actually build all the time without having to do weird things like we do currently, where you disable parts of, can't remember which way around it is, but you disable part of SFC to build OVSDB, and then rebuild SFC once OVSDB is built. So you build things twice to get what you really want. You don't have to do that.
And so really this is about because you can do transactional black application of like more than one patch. Is that right? Or is it version rate?
No, it's just that you add features in an ordered manner, and then you can declare ordered constraints on how you pull those in. But you can't bump the versions of two different projects simultaneously and declare that as a single version bump. It doesn't work. From upstream's perspective, so that's us when we're developing our project. Obviously, the first step is you have to document your API. So however you've decided what that's going to be, but you have to know what it is and then adhere to it and make sure that if your documentation is external to your code, it's kept up to date. And then once you've convinced your downstreams that you're actually a very sensible developer, you'll never break things without bumping the major version, and they trust you and they've started switching to ranges, it means you can do release-based development and ship bug fixes, and your downstreams will benefit from those automatically. So you eliminate the disadvantages of snapshot-based development, but without forcing everybody to change their version numbers every time you release something. And so that ideally should encourage people to release frequently and release often, but actually release something. So when you've got a bug fix, you ship it, well, test it, ship it, and bump the minor version.
What do you suggest during the release time frame? I mean, if the release takes 4 or 5 months, doing that release every couple of weeks, collect all the changes and create.
So well, there's a session this afternoon on the fast phased planning proposal. So we'll discuss stuff like that, I think, in that session. But if you look at the way projects in general are developed in the Java ecosystem, without taking into account Maven's oddities sometimes, but whenever there's a bug fix, you release. Well, if it's important enough, you make a new release and ship that. So you could have multiple releases in the span of a week. Right, but
require all the dependent projects to change their new snapshot. So
no, because you're not working based on snapshots. You're working based on release artifacts, and you're using version ranges, and so you get the upgrades automatically. But so that's sort of in what happens in the general world. When you're talking about a bunch of projects that work together, like an OpenDaylight, things change a little bit, because if you need to decide what you want to do in terms of testing, and if you add lots of releases and you want to test the way things work, assuming people don't necessarily apply all the upgrades all the time, then your test matrix explodes. So there are pros and cons to doing lots of releases, but yeah, so we need to discuss that to figure out what the kind of granularity is that you'd expect. But we're not there yet anyway. And then it also means that, so this also meshes in with the granularity thing. Breaking changes need to be identified before they happen, ideally, batched up as well. So if you decide that you have a breaking change and you know you're going to bump your major version, then you might as well do other breaking changes while you're at it, so that you don't end up at version 17 in 2 years' time. But it also means that you should try to figure out what the support cost of that is, and figure out whether it might not actually be possible to do your change in a non-backwards incompatible way, with support shims or whatever. Keep the old methods and have them call the new ones, and define what the default values are. That kind of stuff, because that reduces the cost for your downstreams. And if the cost, so that's another thing, since we're all multiple projects in the same community, there is an aspect to it that if something costs us as an upstream project, but if doing that means that it costs less globally for all our downstreams, it might be worth doing. Couple of tricks, and then I'll move on to the discussion points. So if you make a mistake and break your API without having bumped the major version, some projects just leave it like that and quickly release a new version with the bumped major. That's wrong, because you've just broken all your downstreams and not fixed them. What you need to do first is do a new bug fix release that reverts to the old API, so that your downstreams will pick up something that's compatible with what they expect. And then you re-release your changes with the new bumped major version. And also, and this is quite an important one for OpenDaylight. Obviously, none of our projects exist in a vacuum. They all have upstreams, either other OpenDaylight projects or third-party dependencies. And when you change your upstream dependencies, if it doesn't affect your public API, it shouldn't change your version number. Well, you don't have to do a major version bump at least. So that means, for instance, if you switch from Netty 3 to Netty 4, you shouldn't bump your major version. And if you have downstreams that were relying on you to provide the transitive dependencies to Netty, and they break, then that's their fault, because it wasn't part of your public API that you were giving access to Netty 4, unless your ODL parent and parts of controller, where we supply artifacts whose job it is to provide upstream dependencies. And so that then the public API is the dependencies that we provide. And so when those change, obviously that doesn't work. But it means that you can change, say for instance, the Yang tools changes something significant. So or they remove deprecated functionality, so there's a major version bump. That doesn't mean then that all the other downstream projects in OpenDaylight need to bump their major version as they integrate the new Yang tools features, unless the changes made in Yang tools result in backwards incompatible changes to the generated public APIs, which could happen. And so this leads into my discussion. First, versions in OpenDaylight. Things are made a bit more complicated in OpenDaylight because we have tons of different version numbers for different things. We have Maven artifacts. And even those are of different natures. So some of them are jars of utility classes. Some of them are Carafe bundles or OSGI bundles. Some of them are artifact POMs. So we don't have many of those yet, but it's something that we're likely to start seeing more of in Boron.
So is it Maven artifacts, OSGI bundles, Carafe features, and Yang revisions?
Well, for me, OSGI features and Carafe features are supposed to be the same thing. But yeah, so I forgot as well, there's OSGI bundles and OSGI features, which aren't the same thing, and Yang revisions. And Yang revisions aren't semantically versioned. And we tend not to bump revisions anyway, because there's all this weird thing where, yeah, you add a new feature and it changes your package name, and so you have to rewrite all your code anyway. So there's a bunch of things that we need to figure out there before we can have a consistent story for all of this. Other things too, semantic versioning only cares about public APIs, but there are instances, I think, in OpenDaylight where it makes sense to care about the ABI. So if you're not familiar with the terminology, API is application public interface, and ABI is application binary interface. Application programming interface, sorry, and application binary interface. And so an ABI is the actual bits and bytes of your artifacts. So things like the order of data in your data structures, the size of your types when you're sending data over the network, or serializing information.
API compatibility can involve recompile. ABI
doesn't. That's, yeah. And so, because we have things like Yang tools that generate code for us, there might be stuff where we want to bump majors because we're changing the ABI, because what's being generated is changed, even though your own code might not have changed at all, but you're building with a new version of the Yang plugin and your ABI is changed. And it has an impact on clustering features, and also our upgrade story, which is another session later today, because if you want to do seamless upgrades without restarting your container, you have to be able to swap data between all the bits that are running in your container that you're changing as you go along. And so maybe your API hasn't changed, but the data has, the format has, and so you really want to bump your major version, because versus Carafe will help you with multiple major versions together, but it won't help you with minor version bumps. Well, yeah, theoretically it will help you. In their public API, it says that they help you. In practice, version 4 at least of Carafe is supposed to do that. There's other things like OpenFlow table usage models as well. Because we have various projects that are discussing trying to do things together in OpenFlow tables, perhaps that could become part of our public API in effect. So if you change the way you use the OpenFlow tables, you need to do a major version bump, because otherwise you're going to have collisions in your switches. And ... because there's undoubtedly things I haven't thought about, and that was...
version skew.
Right, yes, so version skew, that's something else that comes up with this. So it's not related strictly to semantic versioning, but it's when you stop using snapshots. When you stop using snapshots, you start using release artifacts, and so what you really want to do ideally is avoid having tons of different versions at the same time. So there are some things that you can add tools for, like the Maven Enforcer and so on. So that will help you make sure that you don't have too many different... yeah, well, it'll help you make sure that your bug fixes get applied widely. So that, when it comes to new features and major version bumps, you really need a carrot and stick approach, which I think is healthy globally, but it would be a change in habit. So for instance, if the MDCell project decided they need to do a major version bump, then that would mean that all the offset 1 and 2 projects need to change to using that. So it's already the case today. They end up with patches that need to be merged and so on. It takes a while. But if we're using release artifacts, there's nothing to force you to switch to the new MDCell version. The MDCell project would need to convince everybody that it's in everybody's best interest to do so, which I think is nice because it means that you don't do major version bumps just for the fun of it. You actually add value when you're doing that.
The only problem that comes in with that is that because of when you ship a simultaneous release with a bunch of things in it,
yeah,
they all damn well better agree.
Yeah, so that was the other thing. You need to converge towards something.
Integration distribution is the state.
Yeah. And so that's one thing we have in OpenDaylight. There's the integration distribution project at the very end that pulls everything together, and so that could also say if you haven't upgraded to MDCell 2, then you're not part of the release.